In this lecture, we will learn about the decorator design pattern and how to implement it in Python. The decorator design pattern is a structural design pattern. It lets us add new functionality to an existing object without altering its structure. This pattern acts as a wrapper to an existing class and lets you attach new behaviors to objects by placing these objects inside special wrapper objects that contain behaviors. We use the decorator pattern when we need to be able to assign additional behaviors to objects at runtime without breaking the code that uses those objects. We can also use decorator when it is awkward or impossible to extend an object's behavior using inheritance. Let's look at the pros and cons of using the decorator pattern. The pros of using this pattern are that we can extend an object's behavior without making a new subclass. We can add or remove responsibilities from an object at runtime. We can combine several behaviors by wrapping an object into multiple decorators. And it follows the single responsibility principle. The cons of using this pattern is that it is hard to remove a specific wrapper from the wrapper's stack. It is difficult to implement a decorator in such a way that its behavior doesn't depend on the order in the decorator's stack, and the initial configuration code of layers might look pretty ugly. Let's learn how to implement the decorator design pattern in Python. We will create a class named car which has two functions inside of it. One function will be named type, take in the self parameter, and use the pass keyword in the function body. The other function will be named price, take in a parameter named self, and use the pass keyword in the function body. Then we will create a class named Tesla car that extends the car class. Inside of this class, we will create a function named type that takes in the self parameter, and inside of this function, we will return the string Tesla. Then we will create a function named price that takes in the self parameter, and inside of this function, we will return 1 million. Next, we will create a class named vehicle decorator that extends the car class. Inside of this class, we will define the init function that takes in two parameters, self and vehicle. Inside of this init function, we will call super.init. Then we will set self.vehicle equal to vehicle. Next, we will implement the type function that takes in the self parameter. Inside of this function, we will return self.vehicle.type. Next, we will implement the price function that takes in the self parameter. Inside of this function, we will return self.vehicle.price. Then we will create a class named Special Offer that extends the Vehicle Decorator class. Inside of this class, we will implement the init function that takes in four parameters, self, vehicle, discount percentage, and offer. Inside of this function, we will first call super.init and pass in vehicle. Then we will set self.discount percentage equal to discount percentage, and self.offer equal to offer. Then we will define a function named price that takes in the self parameter. Inside of this function, we will set price equal to super with special offer passed in as the first argument and self passed in as the second argument, and then call the price function to get the price. After that, we will create a variable named percentage and set it equal to 100 minus self.discount percentage. Finally, we will return price times percentage divided by 100, cast to a float. Time to test our code. We will create a variable named car and set it equal to a Tesla car object. Then we will print out Tesla base price is, and then concatenate car.price cast to a string to it. Then we will create a variable named offer and set it equal to a special offer object with car passed in as the first argument, 50 passed in as the second argument, and then the string 50% discount passed in as the third argument. Finally, we will print out offer.offer concatenated to the string on Tesla cars, the new price is, concatenated to offer.price cast to a string. When we run the code, you will notice that the Tesla base price is 1 million, and there is a 50% discount on Tesla cars, so the new price is 500,000. In the next lecture, we will learn about the facade design pattern and how to implement it in Python.